These are the question asked last before SC081 Bagmati Province. Yes, this was the question. And yes, let us see the question. Right, this is Rob. Stop out here. And yes, this is question. The first question is relation between angle PSQ and angle PRQ. Let us see. Angle PSQ. PSQ. This is angle PSQ. Yes. And then after another angle is angle PRQ. Angle PRQ. So what is the relation between them? You know. Let me tell you the theorem 3. Let us get back to theorem 3. Theorem 3 is that inscribed angles, right? Inscribed angles or circumference angles standing on the same arc are equal. That means if the inscribed angle are standing on the same arc, then they are equal. That means inscribed angles are equal. Look out here. This angle ARG and angle APG, they are standing on the same arc AG. That's why they are equal. Here, angle TXN and angle TGN, they are standing on the same arc TN. That's why they are equal. Here, same thing. Angle PSQ and PRQ, they are standing on the same arc. Look. They are standing on the same arc PQ arc, right? That's why they are equal. So the relation is angle PSQ is equal to angle PRQ. Or simply you can write equal. Then you will get 1 mark, right? So yes. Next question is experimental verification to prove angle SPR is equal to angle SQR. SPR is, this is angle SPR. Let us check a double angle and SQR. So this and this angle, we have to prove them experimentally, right? So for experimental verification, it's 2 marks or 3 marks question for SE graduate who are going to be graduated from SE. And yes, and here inscribed angle this angle SPR and SQR, they are standing on the same arc, right? They are standing on the same arc, SR arc, right? So we know that they are equal theoretically, but we have to prove them experimentally. For proving experimentally, we have to draw 2 or 3 different radii of different circles, different radii, right? Circles having different radii. And yes, 3 or 4 centimeter, 3.5 centimeter, 4 centimeter. And then after yes, measuring them with protractor, right? And angles should be measured with protractor. Then after yes, we gotta make them equal. And yes, we have to tabulate them in proper data. And yes, summarize and just analyze them and just write the final conclusion, right? That's the thing. So yes, that's, you can prepare and refer to book as well. And C number, theoretical verification to prove angle RQT is equal to angle PSR. RQT. This is RQT, no? This is RQT, no? This is RQT. And another angle is angle PSR. This is angle PSR, right? Let me take different pen, right? Let us take green pen. Angle PSR. This is angle PSR. Angle RQT. This is angle RQT, right? So here. How to prove this? We have to prove theoretically. We are not allowed to prove that experimentally. Further, let me take that to the cyclic quadrilateral. Cyclic quadrilateral means the quadrilateral having all its vertices on the circumference. Look out here. Cyclic quadrilateral means yes, if this is cyclic quadrilateral, then yes, all the vertices are lying on the circumference of a circle. That's why it is ABCD, right? ABCD is a cyclic quadrilateral because all the vertices ABCD are lying on the circumference of circle or not. Yes, that's why it is a cyclic quadrilateral. So here, let me take back to cyclic quadrilateral theorem. This theorem 2. Let us forget about theorem 1, right? There's theorem 2. Theorem 2 is theorem 2 states that the exterior angle. This is exterior angle. Angle WPC. Let us suppose C. Angle WPC is equal to angle C, right? I'm supposing that, supposition, right? And angle WRS is equal to angle R, right? I'm supposing that R. So R is equal to C. That is a theorem 2. That means exterior angle of a cyclic quadrilateral is equal to the interior angle of a cyclic quadrilateral. This is exterior angle, but it is exterior, outside, no? Right? Interior means inside. Interior means inside. Exterior means outside. So outside angle is equal to inside angle, right? And that's the insight, man. Exterior angle of a cyclic quadrilateral is equal to the interior angle of a cyclic quadrilateral. So that is the thing we have to prove here. So how to prove this? So yes, we have to prove like this. Look here. Suppose this is cyclic quadrilateral. So I'm drawing a cyclic quadrilateral here, right? Like this. S, P, Q, R, and T. Let me change the pen, man. Right? So here. We have to prove this angle is equal to this angle, right? This S, this R, this P, this Q, and this T, right? So how to prove this angle? We have to prove this, and this theoretical we have to prove this, right? How to prove? So let us suppose this A, let us suppose this B, We can suppose this or not. And let us suppose this C, right? Now here theorem 1. The opposite angles of a cyclic quadrilateral is supplementary. Look, this opposite angle A plus G is equal to 180 degree. Y plus D is equal to 180 degree. That means opposite angles sum is 180 degree. That means here, look at this and this are opposite angles, no? So A plus C is equal to 180 degree, right? A plus C is equal to 180 degree because opposite angles of a cyclic quadrilateral are supplementary, or the sum of opposite angles is 180 degree. So A plus C is equal to 180 degree. So look out here. This is straight angle B plus C is equal to 180 degree. Why? Because this is the straight angle, right? So this 180 degree, B plus C is equal to 180 degree, A plus C is equal to 180 degree. Both got the same value. B plus C is also equal to 180 degree, and A plus C is also equal to 180 degree, right? That means from this equation I and equation double I, right? B plus C is equal to A plus C, right? Then we can call this and this. B is equal to A. Look, A is equal to B. B is equal to A is derived, no? I have derived A is equal to B or B is equal to the same thing. So here we have to prove A is equal to B, right? Inside angle equal to outside angle. So that's what it is. That's how we crack the problem, man. So yeah, this is all about all about the details of cyclic quadrilateral and inscribed angles. And the question was asked based on inscribed angle and concepts of cyclic quadrilateral. So yeah, that's all for the signing out. Professor artist GoatX, aka professional MotoVlogger, aka hip hop artist GoatX. So that's all for the keep shining, keep grinding. I wish you all the best for IC students. Thank you so much. Hats off to everyone.